Thanks to YOW. Is this thing on? Oh, cool. Okay. Thanks to YOW for organizing this event and for accepting my talk and for allowing me to share my message today. So today I'll be sharing a retrospective on how we built and run our data lake at Atlassian. Just first, a little bit about Atlassian for anyone here that doesn't know what Atlassian is. So it was founded here in Australia in 2002. It's now a global company with over 100,000 customers. And their mission is to unleash the potential of every team. They do this by providing collaborative tools for teams of all sizes. Tools like Confluence, which is like allows you to create documents and collaborate on pages and whatnot. Stride, which is our newest product, which is a cloud-based team communications tool. And Trello, product management tool, allowing you to collaborate on boards, lists, and cards. And there's many others as well. So why a retrospective? Well, I've met with many data teams over the last 6 months, and one question always seems to come up, and that's what would we have done differently if we were to do it all over again? And I've never really had a solid answer here. So I decided to get together with my team and run a retro on our journey up until now and figure out what's worked well for us, what hasn't worked, and I'm hoping that the lessons from our team can help others go further and faster on their data journeys than we have. So a bit about our data lake. It started as a hackathon project. We basically built a proof of concept out in 24 hours. We don't like to call it a lake so much. We much prefer to refer to it as an analytics platform. And the reason for this is it's much more than just a dumping ground of data. We have built a lot of services around it to ingest, prepare, enrich, discover, and present data. So we call it Socrates, and we call it Socrates in reference to the Socratic method. And our hope is that our platform will allow our users to basically do the same thing, ask lots and lots of questions, and get down to the really stimulate critical thinking. So to give you an idea of our current scale, we have over 1 petabyte of data in our data lake. We land about 1 billion events each day in the lake. We ingest from around 100 different sources, and we have over 1,500 monthly active users, internal users. These are other Atlassians, other people in the company. An obligatory tech stack slide. It really wouldn't be a data talk without seeing one of these, I guess. So broadly speaking, these are the technologies we use at each part of our data journey. So basically, I'll start with storage. We only really have S3 as our storage layer. Majority of that data is in Parquet format, but we do sometimes see some other stuff appear, especially when it's self-service. We see some CSV files and whatnot appearing, but majority is in Parquet. From ingestion and preparation, this is enriched data. Initially, a lot of this, when we started the data lake, a lot of it was built in Hive, but I guess in more recent times, we've started to move towards Spark as well. And the idea there is that it's mostly due to the faster processing of data, and just the promise and the progress of the project is a lot better than what we've seen with Hive lately. In terms of query engines, this is basically how people use and query our data platform. So we started off with Presto, and more recently, we've moved towards using Amazon Athena. And I'll get into the reasons for this a bit later. And visualizations. So we believe in trying to provide a lot of options here. We don't think that there's just really one tool that does everything. So we have Redash, which is an open source tool which allows you to do quick visualizations on SQL. We have Tableau for more corporate dashboarding and shit like that. And then Amplitude, which is for behavioral events and clickstream analysis. And then overall, this is our governance layer that kind of goes across everything, Yeah. So we have Anodot, which is for anomaly detection and on stream data. Apache Airflow, which we use for orchestration. Vault for managing secrets and controlling access to things, and Datadog, which we and the rest of the company basically use for monitoring of our platform and our pipelines as well, our data pipelines. So I'll start with, we'll get into the retro right now. So I start with what worked well or is working well. So these are basically decisions that we've made along the way, or the decisions that we made up front that have kind of paid off, and we're quite happy about them. So the first one is having only one data platform, one data thing. That is, we didn't have a data warehouse and a data lake, and that's kind of where we actually came from. We actually had two things. We had, I guess, we were using Redshift to store big data shit, and we had a Postgres data warehouse. And that was quite problematic from a user's perspective. They didn't really know where to go for what. So we didn't want to have that same situation again. We decided on let's just do all this stuff in one thing. And when I did a bit of prep for this talk, I found this table on Google, and the earliest reference I could find to it was in 2015. And there was a clear recommendation from most to keep these two platforms separate. There were a few obvious reasons for it at the time. One was in terms of data, there was not really an easy way to do processed data in a data lake. And that was you couldn't do really well modeled transformed data in a data lake. The technology just wasn't really there. There wasn't really any established patterns either. In terms of processing, data lakes were typically seen as schema on read. That is, you define fields when you query tables, as opposed to RDBMS databases, which are typically that of data warehouses, which are more schema on write, and where you actually define fields when you create and insert, as opposed to, I guess, which kind of encourages more structure. And lastly, security. The security models in big data technologies were really lacking at the time. Fast forwarding to 2018, and things have somewhat improved. So you can kind of do process data in a data lake now, in using these big data technologies. The technology has definitely got a lot better. The learnings by the community have improved, I guess. And there's really no need to have these two platforms separate, in my opinion, anyways. So what has changed? So for example, with there's established patterns for doing ETL, so you can do process data pretty much. There are improvements in columnar formats, so you kind of get schema on write a little bit. The security is still kind of shit, but it's getting better. There are open source projects out there which are, working up in this area and improving things. And lastly, it's easier for business professionals to use these platforms because a lot of the big data technologies now support anti-SQL, which is kind of a common platform across both anyways. So moving on. So another worked well for us is we always try open source first. Doesn't mean we always settle for it, but we always give it a shot first. We always, see what projects are out there and give it our best shot. And companies, specifically data practitioners, are driving these projects. It's not the vendors driving them. So it's quite nice to actually see what companies are thinking as opposed to what the vendors are thinking. So when you consider using open source, there's good and bad about it. The good is you can contribute. You can submit your own PR or fork it or do whatever you want. It's basically you can be in control. It's cheaper, typically much cheaper than going with a vendor-backed solution. There's a community built around these open source projects, sharing tips and tricks, and you can kind of get input into roadmaps. They're often bleeding edge, often releasing features much faster than, say, a vendor-backed solution. And there's a good layer of abstraction. For example, if you're using something like Apache Kafka over AWS Kinesis, it's easier for you to pick up your whole stack and move across to a different cloud platform if you wanted to. The bad, support, and if something goes wrong, you're pretty much on your own, and you should be kind of feeling comfortable to get into the code and fix things if you need to. There's a risk of projects tanking, and one thing that we always do is we look at the community of a project before we start using it. So, we look for things like red flags, is there a sole developer on this project? And if there is, maybe we'll stay away from that. A development cadence. If you see the level of commits slowing down in a project, there's often signs that it's not going to be around for much longer, or there's not much of a roadmap there at all. So that's kind of what I've got on that. In terms of another worked well for us was separating storage from compute. So this is like this was a huge dynamic shift for us coming into this whole project for us. And what I mean here is like using cloud native storage as opposed to like AWS S3 or Google Cloud Storage, as opposed to using instance attached storage like HDFS. And this has kind of become a common practice, and it's often recommended by the 3 big cloud platforms. So we use S3 as our storage layer. And the benefits for us from a storage perspective are it's easier to manage and scale and more affordable. I guess the disadvantages from a storage perspective are you can go out of control and just keep on throwing data in there and not realize actually how much data you actually have until you actually run a query once a year or something and see you have over a petabyte of data. From a compute perspective, there's a lot of other benefits. You can use different compute for different use cases. So for example, we have like one technology for ingesting data, one technology for preparing data, and one technology for like our analytical engines. You can easily shut down compute when you're not using it. So like you're not really paying for things when you don't need to use them. And because clusters, like you can have ephemeral clusters that live for a shorter period of time, you can take advantage of things like Amazon's spot pricing. So you can pay like 10 to 20% of the actual price of a node whenever you're doing compute. You can change compute when you want to. So like I was giving an example before about how we switched out Presto in favor of Athena. And the benefit there for us is like that we didn't really actually need to do anything. We just flicked a switch, and then all of a sudden it's all kind of working for us. And lastly, like there's better accounting. You can clearly understand how much it's costing to land data or compute data, and you can even like get to the state where you can even think about charging back like compute for particular tables to particular business units. We focused on one use case first. So this is another thing that worked well for us. And what I mean here is like when we actually started the data lake and the analytics platform, we thought like we didn't run a really big project. We just focused on one thing, one user. And so what I'm sure like probably a lot of you have seen this before, and what this diagram is showing is like the 2 streams of delivery. One where you basically, your customer gets all the value at the end, and one where you're delivering smaller chunks and adding value along the way. So we kind of tried to think about how we could apply this to doing something like spinning up a data lake. So we thought about like maybe we could think of each of these stages as a different group of users or like a subset of users. So that's kind of what we did. And at Atlassian, we have a ton of different use cases for data. So we have finance for forecasting and bookings analytics, product analytics, which do mostly like user behavior and product feature usage. We have marketing analytics, which is like funnel reporting and campaign analytics, and there's many others. But when we started the platform, we chose to just focus on one user from one of these like departments. And so we chose a marketing analyst who was interested in combining web events, behavioral product events, and billing data to track the full journey of users as they travel, explore like our marketing assets, sign up and evaluate a product, and then measure the usage of features in product as well. And this was something that really hadn't been done or really been possible to do at Atlassian before this, because we had those 2 disparate data platforms. So it was really a good way of actually proving value first and proving that this platform could work. And like, we could easily add on to this, so we could add more and more use cases and eventually get to a state where, eventually all the users could use the platform. Another worked well for us is that we didn't actually kill the old platform, we hid it. So we never actually got rid of the data lake. We just did a little hack to get our new platform moving faster. And the aim for us was to get people and use cases off the data warehouse and onto the new platform as soon as possible. So what we did, we basically have like our legacy data warehouse had incredibly complex models. There was like thousands of hours put into them. And pulling from like a multitude of sources like billing systems, finance systems, CRMs, etc. On top of that, we had a lot of users, around 700 at the time, using the data warehouse through like direct database connections and through BI tools and complex reports. And instead of spending thousands of hours rebuilding these models and not delivering any value for a long period of time, we decided we'll just kind of copy the data across to the new platform. So we used Apache Scoop, and that job just took about 2 weeks to build. So that's it. That's all we did. And then people could start using the new platform immediately. Basically, users could connect. We could start getting our BI tools repointing to that new platform. And at some later stage, we could come back and deprecate the whole environment and rebuild the ETL to the new platform. We haven't done that yet. That's on the to-do list. But that was 2 years ago. I'm sure it will go away eventually. So moving on to what could have been better. So these are decisions that we made that have come back to bite us. For some of these, we found solutions, and I'll kind of explain the solutions when we found them. And for some, we still have no idea what to do, and I'm looking to help, maybe. So one was our team structure. This really hurt us. So we weren't structured in a way that was set up for success. We had the right amount of people in our team, but just not the right focus. So at Atlassian, there's a lot of teams that look to data engineering for help. And we're basically one team trying to do it all. We're building the pipelines, helping with the data questions, maintaining the platform, supplying the tools. But there was a lack of focus. We're basically stretched, and our domain knowledge, we're just incredibly stretched, and we could do a lot of things, but we just didn't really do anything really well. So late last year, we decided to split into sub-teams. One set of teams, which we call the data pipelines engineering, is aligned with business units that have a greater need for data in the company. And we'll build models and whatnot to support the data analysts and data scientists in those particular teams. And then another group we call the analytics platform team, and they're there to do things like provide the self-service tools, the visualization tools, improve the DevOps of the platform for our data engineers, watch and monitor the platform's costs, make sure that we're not spending too much money, and also just keep the lights on, make sure all the services stay up and running. And we've been structured for this for a while now, and it seems to be working pretty well so far, so I think that's a good win. But yeah, we're on what could be better. But it was what could be better at the beginning, I guess. So another could be better for us was we created a data engineering bottleneck. That is, teams relied too much on us, and it became very apparent that we're starting to slow down the progression of others in the company. And basically no one could be autonomous. And there were a lot of self-service paper cuts that we noticed in big data, coming from an RDBMS database to a big data platform. One was there was particular actions you couldn't really do in a data lake or an analytics platform like ours, where you could do it in an RDBMS database, like create table as select statements. That was so hard to do on many analytical engines these days. Or what else have we got? Yeah, that's pretty much it. Compute was harder. So it was a whole new concept for a lot of people, where they came from RDBMS, where they just had one thing. They did the compute and the storage all together, and they had to now figure out how to spin up, manage right-sized clusters and all this stuff. And it's whenever they actually finally did get it, there was the tech-savvy teams who actually did understand how all this stuff worked and fit everything together. They often built things different to each other, and so we just ended up with a variety of ways of actually doing ETL across the company. So what we did to solve this is we created a self-service portal. We've seen similar things like this done. I think Netflix and Airbnb were kind of our inspiration here. And one of the features that we rolled out first in this data portal was the ability, what we call a transformation service, or TAS, transformation as a service. And users could basically enter in a SQL, in Spark SQL syntax, specify table names, schemas, partitions, and then execute it. And they can run it once or schedule it to run on a routine basis. And behind the scenes, what we're doing is we're validating the query, and then we're creating a directed acrylic graph in Airflow, and just executing that on a shared persisted cluster every day. And so far it's been pretty successful. Like we've had, I think, over 180 scheduled transformations running on the service every day. And I think there's around 60 plus users also using the service every day. So it's going pretty well. Another thing that could have been better, we didn't think about our information architecture up front. So this is a problem that's still kind of hurting us currently. And it's definitely something you should plan up front. It's hard to really get any good guidance here. So, you know, any help would be good. I found this definition on Wikipedia, which is the art and science of organizing and labeling websites, intranets, online communities, and software to support the usability and findability of data. So this is a common practice in many information systems, but like I couldn't really find a way to apply this to like data lakes, and there wasn't really any really good examples of how this was applied to data lakes or data platforms. So we have 4,600 tables in our data lake and 155 schemas. So a new user coming onto the platform really struggles to find where things are. There's not really an intuitive design either. It's not like you can just go, oh, that kind of looks like a schema that's got my data in it. There's nothing like that. So it was pretty tough for anyone new. They had to basically rely on their colleagues to try and tell them where to go. To kind of fix this, we've come up with this structure. We haven't implemented this entirely yet. We've got some parts of it, but we're working towards this structure. And it's basically like organizing data at a schema level a bit better. So we have like raw, which is like our source conform data. As the name suggests, this is basically untouched. We just land it as it appears in sourcing systems. We have domain modeled, which is like grouped into common subjects like support or customer or cloud or server, because we're a cloud product. And basically the idea here is our newcomers should just be able to come in and see like these schemas and just go, oh yeah, I think I might be in the support schema. And then we have like team managed, and this is basically where teams can take control of the governance, and they can do whatever they want in these spaces. If they want, they can eventually promote it up into the domain modeled through like some sort of tiering process or certification process. And then lastly, like a sandbox, which we just purge like weekly or something like that. Another thing we didn't really think about was our environment architecture. So I guess that's the problem with doing like an MVP. You just kind of go, oh, this works. Let's just keep building it. And the problems with this is that we have basically no separations. We basically have a whole data platform, dev, staging, test, and production in one AWS account, and that really hurts quite a lot, especially with services like Amazon Athena, which is basically one per AWS account. So you can't really, split things up too much. We didn't have a clean start. Basically, the account that we were actually on before was actually like repurposed to be a data lake, which was also pretty terrible. And it was just basically hard for anyone to do end-to-end testing, because like you eventually had to use a production service to do testing on on anything in development. I don't have the answer here. I don't know. So help. Another bad thing that we did was we pulled data, and we made it our duty to go to each sourcing system and basically pull data as opposed to having it pushed to us. So I'll give you a bit of like a history. So when we started, we set up a lot of batch jobs to basically tap into each sourcing system, and basically using whatever technology was necessary to extract this data. And this was fine for a few sources, but then we started to see like an explosion of microservices. We drank a bit of the microservice Kool-Aid at Atlassian, and like what started to happen was it was just overwhelming for my team, and it's like there was just so many random failures every day. I think we'd spend about 20 to 40% of the day just fixing random failures. So we have got a solution here, and what we're moving towards now is, like at Atlassian, we've spun up a central event bus, and I think there was a talk yesterday in the morning about using Kafka for something like this as well, whereby like producers could send data to a single endpoint, and consumers could subscribe to the events, without having to worry about the complexities of sourcing systems. And we saw like our sourcing systems already start to push events to this event bus for other consumers, like other microservices or other enterprise systems. And basically we thought of this as a good opportunity for us to kind of tap in as well and pull data too. So what we have then is just basically one pipe that we need to maintain, and we just need to watch that one pipe of data coming in. And so far we get like about 220 million events coming through that pipe every day. And it fails probably once every 3 weeks, so it's good. It's working well. This is one I'm still not sure about. I couldn't really say it could have been better or it's like it went well. Like it's just we're not too sure if we made the right choice yet. We're still like waiting to see. We're waiting for more information basically. We only really switched across to Athena because we got sick of putting out fires in Presto. Like Presto was really fucking hard to manage. Like it broke all the time. There was it basically took 1 or 2 developers in my team to keep it up and running all the time. So where it's good, where Athena is good, is that there is no lock-in. It's just another layer of compute. You can easily switch to something else if you want to. You're not locked in. Data is still stored in S3 on Parquet, so yeah, it's basically you can pick up any other analytical engine you want to and pick it up and start using it straight away. The performance is pretty good. We get around 25 concurrent queries running on it without users really complaining, so that's pretty good. The reliability, I guess, has improved a lot from when we started using it about a year ago. And we get lots of platform improvements that we would have to do ourselves otherwise. For example, we had to upgrade Presto once every 3 months. We don't need to really do that anymore now. It's just a service for us. Where it's bad is the cost visibility. So we see hundreds of people using the service, but we don't, like if someone's spending $50 every time they run a query, I can't find them that easy and tell them to stop it. So it's really tough to do that. The flexibility of the service is a bit tough. For example, we have our own Hive metastore, and they kind of want you to use their Glue metastore, and that's annoying because then it's almost locking you in a little bit, and it's not as mature as other things that are on the market. Like if I say for example, Google BigQuery I think has been around since like 2005 or something. Well, 2011 is when they made it public at least. So it's got a long way to catch up. That's pretty much it. That's our retro up until now. I was hoping to have clearer takeaways, but I think that this slide is kind of my takeaway. So I hope that some of you have learned something from this and you can kind of go further and faster in your data journeys. Thanks.